Hello there, as guaranteed. We're getting through the backtracking problems. We're doing number 76. We're gonna about two more away from being completely done with all the backtracking problems and getting into the graph problems. Number 76, great stuff. This is gonna be word search. Word search is a problem where we're trying to find whether the word exists or not in the grid. And I just found, like the way that Neetcode codes up the solution is pretty clean, and I think we should learn from that and use that technique to our advantage for our interviews, because clean code is good code and easy code that's easy to understand is good. So let's learn from it and see what improvements we can make, and let's go from there. So this particular problem, we're just going to be a depth first search, and we're going to do backtracking. We're going to start at every item, and we're going to track DFS if any of them are equal. If they're not equal, we'll move back, and that's about it. If we get to the final item, then we just return true, and then everything just kind of stops once the true happens because of or statements. Yeah, and how long this is going to take? Well, let's say n times m for every item that we're going to start at, and how long if each item's going to maybe take us there. Well, that's going to take us the DFS time, which is going to be 4. We're going to run a DFS 4 times, and we're going to go in 4 directions. Well, actually 3 directions. Well, yeah, 3 directions, because we're coming from a particular direction, and so on and so forth. And so 3 to the n, because for every direction we might be able to go forward or not. But if we don't find anything, we kind of stop in that trail. So on average, it's probably much faster. So let's get started. So the first thing we're going to do is that rows and columns, these constants will be used entirely and in the board and lang board. The reason why we use board is because the board is the row, so basically every row, and now the column is the 0th item and the first item, and we just take every row. Very good. And so then we also have paths that we equal to set that we have seen before. This is going to be a tuple item that we are going to add to the path so that we don't return to the same item, and we're going to remove it after we're done with the DFS, and so that we can move backtracking to original path as we move on forward and backwards in our path. So yeah, DFS R, C, and I. I is going to be the word. If I is equal to lang word, that means we've found the word, because we've gone past the length of the word. I starts at 0, goes past. If it goes past the length of the word, that means we found it. Return true. Then else if, let's do a parentheses. This is a very good one. So R is less than 0, or C is less than 0. So this is out of bounds. So this particular item here is just for out of bounds checking. So if it's greater than rows, or C is greater than or equal to columns. So that's just that bit is out of bounds. Or we found it inside our paths, so that means it has been seen already. Oh shoot, that's a Control Z in paths. Or the last one is that the word of I, let's say the word, that particular item that we're trying to get to, does not equal to that particular place in the board. That means that we can stop now, because we really don't need to move on, because it's going to be wrong already. So return false. With that, looks like there's some issue here. I don't see the issue. It looks good to me, but for some reason this is putting us back here. I'm not sure what's wrong, but it should be fine. Okay, else, unless it's not, then we'll fix it then. I guess it moves it back there, but anyways, maybe we should move this up here. Yeah, and yeah, that looks good to me. Okay, paths.add. So basically, we found the particular position that has our word, that is the correct character. So we add it to our path. Oh, look, we're using this path. Please do not repeat this path. So resolution is the result of our DFS call is going to be the DFS of the 4 directions. So R plus 1, C, and I plus 1. Then or then we're the 4 different directions, and we're gonna copy this. So 1, 2, 3. I guess this is cleaner. Let's get that. Let's get that cleanness going on. I like clean. So that kind of like this. Yes, that's right. And maybe like that, and like this. So that is getting cleaner. And whoops. Maybe we shouldn't be doing that, but I guess it. I mean, you know. So we don't want to move. We're gonna -1 here, and we're gonna do a +1 here, and a -1 here. So we're gonna go in the 4 directions. And then once we've completed our result, we want to remove this particular path so that we can move on to check out another path once we're there. So we remove that and we return the result so that the next caller see, oh look, we went down this path and it was no good. So we don't no longer need to go down the path anymore, and we can try the next path. And remove those items. So yeah. Yeah. Okay. So right now, so for I in range rows, and for j in the range columns, let's run DFS of I and j and start at 0. If this is true, return true. If otherwise, return false. Let's run it. Oh, we have a false. That's no good. Let's see what happened. Oh, that's the problem. So now we're sending in the answer, and it should be good to go. I hope this particular question has you learned something from this question, and that thing that we're learning here is that we are doing a lot of checking here inside our DFS to return false, which is great, and we're checking every item here, and the adding and the removing, and starting at every particular point. And this particular item here. There's a lot going on here that was learned. These parentheses, that was a joyful one. To bunch up all the points. We don't have to use many else-if statements to return false, but that's good. Checking conditions where it can be false, where it could be true, and where it is true. I think this is this pattern is a point that we see in like all of these these backtracking problems, which is pretty joyful. So the thing is that there's always an endpoint where it's true. There's an endpoint where it's false, and there's an endpoint where we should continue, and we should add and remove items from our subsets or sets. And that's how we continue building our paths and building our solution, which is great. And getting a rows here, that's a good one. Letting your paths, checking every item, that's wonderful code. I hope you enjoyed this video. If you enjoyed the video, like and subscribe. And if you want more, check the link in the description below. Thank you very much, and I will see you in the next one.